Welcome to Insectech's Ethical Hacking course videos, module Router Hacking. In this video, we will look at Introduction to Router Hacking, Basics of Routers, various attacks on routers, under which we will look at attacks on default usernames and passwords, various dictionary attacks with some tools, and SNMP attacks, in which we will use backtrack and metasploit, and finally we will look at the countermeasures to attacks on these routers. To start with, a router is a device that forwards data packets between computer networks. In other words, a router is a device that is used to connect two or more networks and moves data from one network to another network. And if you see, the primary functionality of a router is to forward the packets from one network to another network, and basically these routers work at network layer. And in this presentation, this is the router Cisco 7600 Edge router. Now let us see how this internet routing works. If one machine wants to send packets to another machine which is on the same network, packets can directly go to the destination machine without any intermediaries. However, if the destination address of the packet is outside the LAN, then the sending machine sends it to the router, which will generally be the default gateway. And when the router receives a packet destined for a machine which is outside the LAN, then it looks to see if it has a route to get the packet to the destination network. And if it finds any way, then it will send the packet to the next node, and the next node will send the packet to the next node, to that next node, and finally the last node will drop the packet to the destination's address. So this is how internet routing works. Now let us look at the lab setup for this particular router hacking module. We have the backtrack instance, which is actually installed within VirtualBox, and the target is Vyatta software based router. This is also installed in VirtualBox, and the attacker's machine is having an IP address 192.168.56.101, and the target machine is having the IP address 192.168.56.105. and this Vyatta is a software based router which can even act as a firewall, and these two are connected in a LAN. Now let us try to scan the target router using Nmap, which is already installed on backtrack instance. So let us quickly open backtrack instance and let us try to find out what are the open ports and what are the services that are running on the target router, and let us try to attack if there are any possibilities. Before actually starting the scan with Nmap, let us first check whether these two systems are communicating or not. So I'm just sending a ping request 192.168.56.105, and great, it is getting responses from the target router. So these two are in communication. Now let us quickly launch an Nmap scan against the target router. Let us start a simple scan 192.168.56.105, and let us wait for the response. Great. Nmap scan report for 192.168.56.105, 996 closed ports, and we have 4 open ports which are having some interesting services. One is Telnet, SSH, and HTTP is running on port 80 and HTTPS on 443. Let us try to find out the service versions and operating system and all by using the flag -a. It is taking some time. Let's hope for the best results. Still enumerating the services. Finally we got it. Let us scroll up, and great, this is where we are running our command, and you can see the scan report over here. Host is up, 996 closed ports, 22 TCP open, which is running SSH secure shell, and the next one is telnet, which is on port 23, and if you go down, we can submit this particular fingerprint to insecure.org, and we can go down, and great, we can see the operating system information, that is Linux based operating system. A target is running on Linux based operating system, and however we got some information about the target using this nmap scan, and we can see the port 23, which is telnet, is opened. Now let us try to log in to this telnet using netcat utility, netcat 192.168.56.102, and telnet is actually running on port number 23, and sorry, the IP address is 105. Great, it is asking for the login. Let us try admin. Oops, login incorrect. Now if the administrator is not so intelligent, what he might be using the default username and password of his router. So since it is Vyatta router, let us look at Google results to default username and password for this Vyatta router. I have already browsed, and if you go down, you can see here are the default accounts with the Vyatta password, and we have two default accounts for Vyatta. One is Vyatta login Vyatta and password is Vyatta, and another one is we have root. So let us try to, here are the default accounts for with the Vyatta password. One is Vyatta username and Vyatta password, and one is root is the username and Vyatta is the password. So let us go back and let us try Vyatta. Oops, let us try it. Vyatta and password is Vyatta. Great, we have logged in, and now we are able to access the shell of the remote router, and we can now run some arbitrary commands to see the information. I'm just typing the command show config. You can see the configuration information of the remote router, and you can see it has two interfaces which are running on these IP addresses, and it has some SNMP service enabled. The community string is public. We'll look at it later in further attacks, and this is how we can simply attack the remote routers which are having the default usernames and passwords. Now let us quickly go back to a presentation. Many users don't change their default username and password, which we have seen just in our previous attack. It is the human error. Human errors are good for hackers, and we have seen the demonstration of the default demonstration on how we can attack the default username and password vulnerability. And now let us look at the dictionary based attacks. This dictionary based attack tries all the phrases or words in a dictionary, trying to crack a password or key. A dictionary password cracker simply takes a list of dictionary words one at a time to check with the actual credentials. If they are equal, the password is considered cracked and the word tried from the dictionary list is the password. So let us now look at a simple dictionary based attack on the target router. Now I'm just going to open the dictionary of my attack. I have 5 username and password combinations, and the tool I'm just going to use is Hydra. To launch Hydra, go to backtrack, exploitation tools, privilege escalation, password attacks, online attacks, and Hydra. I'm just going to use the command line interface of Hydra tool, and here is the usage. We have couple of options. We can simply use -L and the username and -P with the password, or capital -L with the username file with the usernames, and capital -P with the file with passwords, and we can simply launch our attack. But in my case, I'm just going to use -C, which is the colon separated usernames and passwords. We can see that here I'm just asking the Hydra, asking our Hydra tool to use this specific word as username and this specific word as password, which are actually separated with colon. Now let me launch my attack. As we have already seen, telnet port is opened. I'm just scanning the the target once again with nmap. Great, telnet is opened. Now let us start our Hydra. Hydra -C, which stands for the file with colon separated username and passwords, and my file name is login, and we need to give the target IP address 192.168.56.105, and it is running on telnet. We want to crack the telnet password, so I'm just pressing enter, and it has launched 5 login tries because we have 5 username and password combinations. The attack is finished. Great, we got the login, username as Vayata and password as Vayata, which is true. We have just logged in using the default username and password in our previous attack, and this is the username and password of this specific router. Now this is how we can actually crack the remote usernames and passwords of telnet or HTTP or any service which are having the user credentials using brute force dictionary based attacks. The only requirement is the dictionary should contain the username and password. This is the difficult part of this particular attack. If the dictionary doesn't contain the username and password of the target, the attack will fail. So let us quickly go back to our presentation. We have just gone through a simple dictionary attack using Hydra against the remote router, and now let us look at the SNMP based attacks. SNMP stands for Simple Network Management Protocol. this is a mechanism for managing network and computer devices, which is actually being used by network administrators generally, and this SNMP service runs on port number 161, which is UDP port. And we can use we can even change various configurations of a specific device which is actually running SNMP via this SNMP manager. Now let us go to our Vyatta router and let us see the command show config to show the configuration, and you can see SNMP service is enabled, which is actually running with the community string public, and the authorization is read only. It means an SNMP manager can read the configurational information on this particular router, and since SNMP is enabled with community string public, the device is capable of receiving SNMP commands by an SNMP manager, and an SNMP manager can read the configuration information with he can only read the configuration information since it is having the authorization read only. If it is having the authorization read and write, the SNMP manager can read and write the configurational information on the router. Now let us look at how an attacker can gather information about these SNMP services remotely. Let's quickly go back to our Backtrack instance, and I'm just going to launch the tool snmp.snmpenum.pl, which is actually running which is actually written in Perl. SNMP enum, which is under information gathering, network analysis and SNMP analysis, and which is here SNMP enum, and you can see it has 3 parameters. One is IP address, community and config file. Let's quickly give an ls over here, and this is actually this SNMP enum tool is actually used to pull the SNMP information from the remote router. And now let us look at the file cisco.txt. Let us give a simply cat cisco.txt. Generally this SNMP consists of MIBs, which stands for management information basis, and you can see here is the dotted notation which indicates how we can traverse the SNMP MIBs, and this cisco.txt, linux.txt and windows.txt contains various SNMP MIB descriptions, using which we can get a particular information about the target device. Now that the last parameter, which is config file, can be any of these 3, like windows.txt or linux.txt and cisco.txt. Let us now quickly give snmp enum.pl, snmp enum.pl, and the first one is IP address, which is 192.168.56.105, and community is public. As we have seen, the SNMP service is running with community string public, and config file, let us give linux.txt, and now you can see the information. These are the ports that are listening on 22, 80 and 443, and these are the listening UDP ports. 161 is actually of SNMP. Let us give a quick nmap scan to these UDP ports, nmap-su, which is for UDP scan, and let us give 161 port number, which is actually running SNMP service, and let us wait for the results. Great, we can see SNMP service is running on the remote system, which is on port 161, and if you see, this is the system information. It's Vyatta v606r1, and these are the mount points we have on the remote system, and these are the running processes, currently running processes on the remote system, we can see, and these are the running software paths, This is how we can gather a lot of information about the target routers using this SNMP enum. Now let us give cisco.txt rather than linux.txt and see if we can get any juicy information. Great, these are the interfaces that are running on the remote system, remote router, and if you go up, this is the system information, and it is actually giving the uptime also, and host name is Vayata, and these are the IP addresses running on the remote system. This is a low back address, and this is actually running on 80 and ETH1. This particular IP address is running on the interface ETH1, and so this is how we can gather information about the target routers using SNMP enum. Let's quickly go back to a presentation. And now we have seen how we can gather information about the router using SNMP enum. Now let us have a quick demonstration using Metasploit against this router. I'm just going to launch my Metasploit using the command msf console. We're just going to launch an SNMP based attack on the remote router, and if you're not sure about how we can use this Metasploit, please go through Metasploit module and come back. Great, Metasploit has been launched, and now let us search for the scanners that are associated with SNMP based attacks. So I'm just using the command search SNMP, and great, we got some auxiliaries, and you can see one tool which is SNMP community scanner, which is actually scanner SNMP login. This is to scan the community strings, and I'm just going to use that specific scanner, which is use SNMP scanner SNMP login. I'm just copying it and I'm just pasting it over here. And now look at options, available options using the command show options. You can see this is required and set. Brute force speed is 5, it is already set, and batch size is set, and R hosts is required and it is not set, and R port is by default 161, we have seen it, and rest of the things are already set. So let us quickly set R hosts to the remote address 192.168.56.105, and now let us look at the options again. Great, everything is set. And now before actually launching the attack, let us see what this text file is doing. This is the pass file we have, and I'm just going to open it using the command cat. You can see it is having some list of passwords saying public, private, 1 2 3 4, 2 read, 4 changes, admin, Cisco, IBM, ILMI, and many more. This is actually the Metasploit auxiliary module, which is a scanner, is actually going to brute force for the community string, which is actually having all these passwords. So now this tool is going to put all these passwords one by one, and if anything is matching, and that is gonna be our community string. So let us now start our exploitation part just by typing exploit, and you can see all these passwords are getting trying to match with the existing community string, and finally it is validating the results, and you can see the host provides read-only access with the community public, and that is what we have seen. You can go back, it is having authorization read-only and the community string is public, and this is how we can use Metasploit to launch attacks against SNMP based vulnerabilities. The idea behind this specific attack is to find out what is the community string that is actually being used on the remote router and what is the access that is provided to the SNMP manager. So let us quickly go back to our presentation. We are done with SNMP, enum and Metasploit demonstrations against the routers, and that's all with this video. Special thanks to Vivek for being such a great resource, and thank you.